Okay. Thank you for joining me for this video. Hello to Algebra 1 students. And let's jump right into the assessment 1 for distance learning problems 5 through 8. So we're going to solve h minus 104 equals 7. So first thing, h minus 104 equals 7. We can just add 104 to both sides. So 104 plus 104, that cancels out here, and plus 104. Well, let's see, 100 plus 4 plus 7, that's really what that is. So what's 7 plus 4? 7 plus 4 is 11. So h equals 111. Or easier to see, 1, 1. Okay, next problem is k thirds, k over 3 minus 9 equals 12. And it would be tempting to get rid of the 3 first, but remember, and I always think of, please excuse my dear Aunt Sally, but that's just a mnemonic device. It's parentheses, exponents, multiplication, division, and addition. And subtraction. So addition, subtraction go together, multiplication and division go together. And if you see anything that's in parentheses, and do that first, and then exponents, and then multiplication and or division, and then addition and subtraction. Well, with this, we're kind of unfolding it to get back to what k would equal. So we're sort of doing the reverse of that. So if we start with this, it's not going to work. So as an experiment, let's not do what we should do first, which is to add 9 to both sides. Let's get rid of the 3 first and see what happens. So this time, if I multiply both sides by, let me write this out, k over 3 minus 9 equals 12, and multiply both sides by 3. Well, then the 3 wipes out over there. And then you have minus 9 equals 12 times 3 is 36. And then add 9 to both sides, right? You want to get 36 plus 9. 36 plus 9 should be 45. So then you have k equals 45. But then if you try to check for that, 45, let's just for simplicity, and let me just say 45 divided by 3 minus 9 equals 12. 45 divided by 3 is 15. 15 minus 9, does that equal 12? Well, 15 minus 10 would be 5, so minus 9 would just be 6. 6 does not equal 12, so Houston, we have a problem. So let's double check where we do the problem the correct way. Then do PEDMAS in reverse order. So again, we have k over 3 minus 9 equals 12. And we add 9 to both sides. So add 9. And then 12 plus 9. 12 plus 10 would be 22. So if you're just adding 9, that's going to be 21. And then now we can get rid of the 3 and multiply both sides by 3. And those wipe out. And that wipes out because if you have 1/3 times 3, it's just going to equal 1. So going back to this, k equals 21 times 3. 21 times 3, 20 times 3, that's 2 times 3 with a 0 in front of it, so that's 60. And then we've got 1 times 3, so that's 3, so the k equals 63. And then let's check it. 63 over 3 minus 9 equals 12. Let's see, how many times does 63, or how many times does 3 go into 63? 3 goes into 6 twice, and 3 goes into 1, so 3 times 21 is 63. And then 63 divided by 3 is 21. What is 21 minus 9? Does it equal 12? Well, let's see, 21 minus 10 would be 11, but we're only subtracting 9, so yeah, 21 minus 9 equals 12. So that would work. And that would be the answer, D, 63. So the answer to that one is 63. Looks like the answer number 5 was 111. And then this problem, number 7, has all these funny rules. It says, which property can be used to solve 7y minus 15 equals negative 29? Select all that apply. So first, let's just solve the problem. We have 7y minus 15 equals negative 29. So we know the first thing we're going to do, like we just did, was add 15 to both sides. So whatever we do to one side, we have to do to the other, right? So then plus 15. Okay. That wipes out. So we have 7y equal to, and then negative 29 plus 15. Well, if we're adding 10 to negative 29, that's going to go from negative 29 to negative 19, because it's not as negative. It's 10 less negative, so to speak. And then 19, well, there's a 5. We're going to add 5 to that. So really at that point, we're at negative 14. And then we divide both sides by 7. And we have y equal to negative 2. Okay, so now we know all the steps we went through. Identity property of multiplication. Is that how we solved it? Well, the identity property of multiplication, I'm going to use blue, would be like a times 1 equals a. Anything times 1 is itself. And so at that point, we look at this problem. We never did anything like that, so we're going to strike that out. We did not use the identity property of multiplication. Additional property of equality. When we added 15 to both sides, and that's what that is. If A equals B, then A plus C equals B plus C. Whatever we do to one side, we have to do to the other. So that would work. Let me just rewrite that. A plus C equals B plus C. So that would work. Okay, next. So we know that that's one of the properties. We're not going to strike that one out. Distributive property. Distributive property would be if we had something like 3x times 2 plus x. And we'd be multiplying this by this and this by that, but that doesn't really look like anything we just did, so that's not going to work. We're going to strike that one out as well. Inverse property of multiplication. That would be like what we did to solve one of the other problems. So if you had 1/5 of something and you multiplied it by 5, you'd just be left with 1. Or if you had 2/3 times 3/2, that would also just equal 1. You're multiplying by the reciprocal, which is taking the fraction and flipping it over, where the numerator and denominator take opposite positions, if you can think of it that way. Numerator is the thing on top here. Denominator is the thing on the bottom. So numerator, denominator. So we didn't do anything like the inverse property of multiplication. Next one would be the commutative property of addition. And that would just be the idea that if you have, let me erase this. If you have A plus B, that would also equal B plus A. So then, could we have solved that problem in the reverse order? So for instance, what we just did was we added 15 to both sides, but we could have added 29 to both sides. So negative 15 plus 29 would have equaled 14. We would have had 7y plus 14 equals 0. And then we could have subtracted 14 on both sides. So we would have had 14 equals negative 7y, and then divided both sides by negative 7, and we still would have ended up with negative 2. So yeah, we could have solved it in the reverse order, just like A plus B equals B plus A. Still the same answer. So that would be the two answers to that problem. And then finally, we have problem 8. So for problem 8, says, where is the square root of 95 located on the number line? Is it between 7 and 8? Well, we're thinking what they're trying to do is get us to focus on perfect squares, like 7 times 7 is 49, and 8 times 8 is 64. Well, whatever the square root of 95 is, that would mean that it was somewhere between 49 and 64. Now that doesn't make sense. Let's go to B. Let's wipe that one out first. So B, we have 8 times 8 is 64, and 9 times 9 is 81. Well, 95 is not between 81 or 64 and 81, so that doesn't work. Next, we have 9 times between 9 and 10. Well, 9 times 9 is 81, and 10 times 10 is 100. That wouldn't really work. I'm going to put a little star. And then between 10 and 11, 10 times 10 is 100, and 11 times 11 is 121. So that's way above. That doesn't work either. The only one that actually works is 9 and 10. So that's the answer, C.